Okay, so up to this point, okay, a lot of our big concepts dealt with cells. Okay, well, different types of cells, different shapes of cells, different functions of cells, what's coming in and out of cells, what the, let's say, breakdown of those cells are as far as, well, do they gain energy by obtaining light or taking in carbon dioxide or both? So my point is, probably up to this point, it's been very, very slow, boring. Uh, we're integrating, let's say, uh, a student teacher into this who needs to gain experience, and it makes it difficult. And especially like today, I figured I was going to be out of here perhaps in another 15 minutes due to uh, perhaps drive bus, but someone outside the district is driving, so therefore it doesn't take away from our bus drivers. So then that's where I would fill in to drive as a substitute for their route. Okay, but when you look at the heading up on top, we've got DNA, RNA, and protein synthesis. Okay, and I'm not saying that everything we're talking about here is always going to be interesting. It's just not going to be that way. And even when you get out into society, you're not always going to get everything is always going to be so interesting and so great. Even in the job that you have gone to school for 2 years, 4 years, maybe 6 or even more than that. Okay? There's always going to be that aspect to where something about your job you're probably just not going to like. Okay? So, for instance, who could we pick on in here? Who knows that you're 16 years old, we're going to say give ourselves another 8 years and say, well, we're 24 now. All right. Who can we pick on that's 24? Okay. What do we plan on doing when we're 24 years old? Okay, at what? Well, we asked who thought they were going to know what they were doing in 8 years. Okay, what are we doing? Okay, so do you think there's something about I'm sorry, you said you weren't sure yet, so we skipped you. So is that going to be for sure? As of right now, if you're a senior, you're going to be going to power linesman school. Okay? Do you think there's going to be something about that job you're just not going to like? I think everyone would probably say, yeah, there's always going to be that aspect. When I think of power linesman, okay, especially in the wintertime, it would be no surprise of mine. What, just down the road here, is that Touchstone Energy? Or is that XL or Sioux Valley? That's right. So with that, when you see them large trucks go rolling out, especially like I said, if it's in the wintertime, could be such a thing. We've got some freezing rain, and all of a sudden you have that ice starting to accumulate on the highline wires. The wind picks up, and then like a whole bunch of dominoes, these power lines tip over. So it's probably no stretch to the imagination, at least I think it's probably possible, that some of them individuals are probably putting in anywhere from 70, 80, maybe 90 hours a week. But when that happens, as you all know, well, I shouldn't say all know, typically what happens once you've gone past 40 hours? It's overtime, which means everyone says overtime, but what does that really mean? Could be. Probably. It's not necessarily time and a half. Yeah. Could be double time. Could even be triple time. So if we're looking at $16 an hour, maybe it is time and a half. Maybe it's 24. And if it's double, well, then you're looking at 28. Then if it's triple time, maybe you're making $48 an hour. Okay. So with that, Some people may decide to, I'm not saying they do, but maybe get out of that profession because they don't like working in the dark, in the winter, and the cold, and whatnot. Like I said, it's not everybody. I'm not saying that's possible, but that could be a deterrent. Okay? Is everyone done with the stapler? Thank you. So, but it is our goal to make everyone a well-rounded individual. So once we do leave this building and get out in society, we're ready to go and hopefully make you a better person for it. It's no one's goal in this hallway to I'm gonna step on them, squish them, and we're gonna make it absolutely miserable in here. How many think it's, and I wouldn't expect you to raise your hand. Hopefully we don't think it's miserable in here. At least that's not our goal. But I think when you look at this, it's talking about DNA, that's possibly something that might interest you. Just by looking at DNA, how many of you think, yeah, I think this is going to be all right? Okay? So with that, let me ask you this. What do we know? What do we know about DNA? It does, and it can. Okay. So we're getting a little. Chances are everything you said is probably right, but let me get caught up here. I'm probably getting a little ahead of myself. Let's try this one. Okay. Should we put a template on there? I don't know. You like any of these? Just keep it plain black and white. I think that was kind of cool. Yes? No? This one? Okay. So now let's see here. I think no, it's this one. No positions. I think isn't one of them random? Oh, this one. Okay. And then I think design. I think isn't it like apply all? Transitions. If we layout. But I thought there's something that you hit that you apply this template to all of them. And I can't quite remember how that's done. Slideshow, transitions, design. Should be something over here. Yeah, I heard they said, well, you know, PowerPoint, and you probably do. But what I don't get, browse for themes. Why is it not? If this is the design we picked, why can't we apply that to all of them? This one? Yes, I have.
On this side.
On this side. This one?
Whichever one that you have. Right.
Yep.
It doesn't look like anything.
Nope.
Is there a search button?
Let's see here. No, we don't want to close. Well, we'll come back to that another time. How's that? Okay. So, what's that? Thursday. How's this Thursday, next Thursday? 24. 17 and 7 is 24, right? That is if my math is correct. Right? 17 plus 7.
24.
Yeah, I think it's 24. Okay. So when we look at this here, this idea of protein synthesis, that's a very vague term. Okay? Because in some of your earlier questions, what are the building blocks of proteins? It's a specific type of acid. No. Amino acids build proteins. Now, so proteins can be anything from blood clotting agents, it can be enzymes, it can be even venoms. Okay? So I once did a research paper for class through SDSU that entailed if animals like the Israeli scorpion or perhaps the cottonmouth or even eastern diamondback, if that venom gives a person, I shouldn't say gives a person, but causes such extreme pain, what is it that we do to treat individuals that have been envenomated? You have to have anti-venom. So if we take the cause is, if it causes pain, well then, is it a stretch of the imagination that, and I don't think it is, but it's above my intelligence level, that maybe you could synthesize a serum that does just the opposite? Because what is possibly part of the problem with morphine, Oxycontin, fentanyl? You can get addicted to those. But if you had something that was just natural, okay, synthesized from an animal, well then perhaps that's something that would be way more effective and maybe non-addictive. Okay, so proteins are also, like I said, enzymes that cause metabolic reactions to take place in our body. Okay, and does anyone possibly know something like, let's say they're a cancer survivor, but when they're in the hospital, they're maybe taking a drug called warfarin or Coumadin or something to that effect. You don't know what those drugs are, but what they do is thin the blood. Okay? And my uncle went through that, where old military man, that typically when you see veterans or people in the military, every day possibly, after taking a shower, step in front of the mirror and maybe do this type of, what I want to say, getting ready for the day. Besides taking a shower, what might they do in front of the mirror?
Comb their hair.
Besides combing their hair. Brush your teeth. Remember, we said they're military people. They probably shave. Okay, because in the military, you can have a mustache, but that's why someone's in the Army, the Air Force, Navy, they're all clean shaven. That's just one of the dress codes of being in the military. Okay? So, the point is, like I said, old military man, shaving. He's on Coumadin. Does anyone think they know where this story's going? Say that again. Okay? Cut himself, bled and bled. It wasn't nothing serious, but he just couldn't get it to clot. Why is that? Because he's taking blood thinners. That's right. So what happens is your liver naturally synthesizes, I think, two proteins. One of them is called fibrin. The other one's thrombin and fibrinogen. That's what I'm looking for. Those are clotting agents that your liver actually makes. And those are enzymes, and enzymes are proteins. And that's what we're looking at here for protein synthesis. So, when we get to this entire process, it has to start with the directions. And the directions are found in the form of DNA. Well, what is DNA? And that's what we're answering. So when that happens, I think sometimes they get that score back and they think, oh my gosh, what am I going to do? Well, for one, it was just the first time maybe you have taken that. And two, maybe you're not getting the scholarships that you think you want. But is it going to keep you from going forward? No. Because, well, I got this score. And I'm not a dumb person, he said. It wasn't what I would have expected that he told me. Again, my point is, it's just a number. It's not a you think it's a reflection on yourself, but it's really not. Okay? Only the biggest critic is always going to be yourself. Okay? So let's not beat ourselves up over that. And that thought just popped in my mind because some of you are taking that PSAT test. And hey, I think that's great. Okay? So, as we're looking at this, okay, when we're looking at nucleotides, there are 5 of them. Typically, you think there's only 4, but really there's 5. Okay? One of them is called thymine. The other one's called cytosine. Then there's uracil, which is one that people typically forget, and I'm not saying for good reason. So I said cytosine, thymine, adenine, and guanine. Okay? These are all individual nucleotides that make up what DNA is. Okay? We're not too concerned about what this sugar is because one of them in DNA just is missing an oxygen. That's why it's called deoxyribonucleic acids. The other one, RNA, which we're talking about here, is formed from ribonucleic acids. Okay? We are more so concerned, for those of you who go on to take organic chemistry, when we get to the biochem portion, then when we start talking about the individual amino acids and the sugars that make up DNA, yeah, this is going to be a little further in depth. But at this level, we're just saying what this DNA is. It's just a 5-carbon sugar with phosphate bonds and nitrogenous bases, cytosine, guanine, thymine, and adenine. Okay? And that's what we're referring to right here. Okay? So one of the aspects we'll be talking about tomorrow, okay, or I should say, perhaps Mr. Holt will be going through this, what we call DNA replication. So let's say, for instance, let's see here, you two, which one of you can I pick on? Okay, so you're dribbling the ball down the court. Okay? So the opponent has 6 team fouls against them. There's a foul called on you, not on you, the person guarding you. Okay? So now there's 7 team fouls on your opponent. You had the ball when you were fouled. What does that mean? Okay? So what that means then, you correctly said, one-on-one. I said there's 6 team fouls. He gets fouled when he has the ball to make 7 team fouls now. It doesn't matter. There's 17 fouls. It doesn't matter if it's in the first quarter or late in the second quarter or the first half. If you reach 17 fouls, it's 1-on-1, like you correctly said. Okay? Let's not get so hung up about when this happens. Okay? But the idea behind that is, or even if it's late in the game and you got 2 shots, you come up to the free throw line. Okay? First one, nailed it. So what you want to do is replicate that thought process. What does that mean then? Muscle memory, and do the same thing. So what do you suppose when we replicate DNA? What's that going to mean? Make the same thing. Okay, so to wind up today, does everyone have this information that wants it? Yes. Yes. Okay, so my next question would be, is if we do some drawing on the board, you say that there is a glare. Is that still the case? Sometimes it matters what time of day it takes place, if the sun is out. Okay, so my question would be then, so if we shut these off, okay, do we want more, I think, on, so here they come. Okay, is there a glare on there? The reason because if you look up these ballast lights, I think that's what you call them, is that when you just flip one of those switches, it just turns 2 of them on, okay? And it's the outside too. So therefore, you're getting some light and it's not incredibly bright in here, okay? Agreed? Okay, so someone give me a nucleotide. What are they? There's 4 of them. I'm waiting for a nucleotide. Guanine, adenine, thymine, cytosine. Okay, so as we look at these, okay, what does guanine bond to? What does adenine bond to? What does thymine bond to? I almost want to say bond to. Okay, so if you see cytosine, it's going to bond to guanine. If you see guanine, it's going to bond to cytosine. So when we write those 4 down there, we just want to show who's bonding to what. Okay, and uracil is going to be another one, but that's associated with RNA. Now, how many of you are maybe looking at this and just thinking, I'm not going to be able to keep them straight? And if you think that, chances are you're probably not. It's like going back to your case. You're down by 1. Chances are, if you shoot and miss that first one, what's the likelihood of making the second one? Pretty high? Oh, okay. So my opinion would be the other way around. But my point, if you think that you're not going to be able to remember, well then you're probably not. Okay? So do sometimes some of these little mnemonic devices help you? Just a little phrase or a little saying that helps you out as far as, oh, well, if I remember that, that's going to help me out in the long run. The reason I say that, you have to know where you're at to know if you're coming or going. How does that pertain to this? You have to know where you're at to know if you're what? Coming or going. Does that make sense? You have to know where you are at to know if you are coming or going. Okay? So, with this, if we've got this double helix, it's called a double helix, okay? That means, kind of draw a big snowman here. And again, I think a lot of you who are maybe not getting the grade that you want, typically in my experiences, this is when things really start to turn around, because now you can actually see something. It's more interesting. If something is more interesting, is it going to be easier for you? Perhaps. Okay. At least that's the goal. So now, next thing, someone please start shooting out, well, not shooting, but telling me some nucleotides. Okay, so if we didn't have this, okay, so I'm going to take that away. So to bond these, what do we say? You have to know what to know if you are what? Yeah, you have to know where you're at to know if you are coming or going. So, what do you think bonds to cytosine? Or guanine, I mean. What bonds to thymine? You have to know where you're at to know if you're coming or going. Okay? So, adenine. I mean, if one's going to be one, it's just probably going to repeat itself. So, cytosine. Okay. Now, one last thing. Let's see here. Use this one. So, what is it you think these are? What type of bonds holding this molecule together? Was in that last thing that you wrote. This type of bonds that holds DNA together. At least I think it should have been the last thing that you wrote. Hydrogen bonds, okay? So, the reason that's important, okay, is because there's an enzyme that's going to break this apart so these can be replicated. Okay? How many of you, now this is the movies, of course, and that's why we go to movies, because they're entertaining. How many of you had ever seen the original Jurassic Park? Jurassic World, but Jurassic Park. Okay? So in theory, if you're a good fan of the franchise or movie, in theory, what did they do in the movie to fill in the for these missing dinosaurs' DNA? Okay, right. So it's scientifically accurate that you can probably still find, at least in my opinion, dinosaur DNA in some of these. When we say petrified, we just mean some of these mosquitoes that may have been around the time of the dinosaurs, but have been preserved in a type of what we call amber that may still have some of the blood or DNA of these dinosaurs in it. Now, is that accurate? I would like to think so. But if there were missing parts of that dinosaur DNA, like if this is just a short strand of it, it's probably not going to work to take it from another species. It just doesn't work that way. Although in certain cases, some of these crossbreeds you can do are actually kind of unique, because if you cross a horse and a donkey, you get a mule. That's neither one of the two species, but they're both mammals. Okay? Oddly enough, you can take a male lion and a female tiger and make a liger. Do you really believe that they exist? Yes, ligers exist. So if you're standing, where are the shoulders of these ligers at? A lion's shoulders, a big one's probably about right here. The front shoulders. Probably the front shoulders of a liger then, I would venture to think are probably about right here. But the problem with getting bigger, okay, it's probably not going to be very successful just because of having all that extra weight. But this is going to be some of the concepts that we're going to start to cue in on. What DNA is, what holds it together, what breaks it apart, and how do these assemble with one another. Now that doesn't mean anything to you right now, but in case you are somewhat curious, I'm willing to bet if we look at chapter 10 in here, it's our philosophy that it's better to start with this rather than jumping into genetics. So, what would you guess that we're trying to simulate when we look at that? What is that? Even though I can't draw in 3 dimensions like what they do here, yeah, it looks like a molecule of DNA, and that's what we're illustrating up here. So we will begin or continue with this information tomorrow, so we will catch up to you next time.